All right, today we're going to move on and talk about how to multiply integers. And I have some good news for you. Multiplying integers isn't as confusing as adding and subtracting integers are. And again, notice I didn't say it isn't easier because, to be honest with you, I don't think adding and subtracting is hard. It's confusing. And what's confusing is in addition, you don't always add. Because in addition, if you have the same signs, you add and then bring in the sign. But if you have different signs, you actually subtract. Even though it's an addition problem, you subtract and take the sign a larger amount. And in subtraction, you change subtraction to addition by changing the number you subtract by to its opposite. But then you follow the addition rule, which means even though you're changing subtraction to addition, if the signs are different when you change it, then you're still going to subtract. So again, that's confusing. Multiplying is a lot less confusing because in multiplication you always multiply. However, I do have to give you a word of warning, and that is you must multiply correctly. So even if you know the rule for multiplying integers, if you make a mistake multiplying, it's still going to be wrong. But again, the good news is in multiplication, you always multiply. And you say, well, if you always multiply, what's the only thing that could be different? And the only thing that could be different is the sign on your answer. Now, when I explain to you the rules for adding integers, I use the fact that positive was having and negative was owing, and I used the fact that addition meant to combine. And when I explain subtracting, I also use the fact that positive is having, negative is owing, and subtraction means to take away. And we figured out the logic between those things. In multiplication, I don't think it's a good idea to try to use positive as having and negative as owing, because personally, I don't understand how you could owe times, all right? So instead, I want to teach you or explain to you how to multiply integers by using math. And you go, by using math, what do you mean? Well, if you remember way, way back when you were in 5th grade, at the very beginning of the year, I told you all math was patterns. And if you could find the patterns, you could understand the math. And remember, I gave you the card trick, and your assignment was to find the pattern that made the card trick work. And again, here, to figure out how to multiply integers, I want to use a pattern. And the pattern I want to use here, okay, is your times table. And you go, your times tables are not a pattern. Sure they are. Look at it. If I had 1 times 1 equals 1, and 1 times 2 equals 2, and 1 times 3 equals 3, that is a pattern, okay? This is 1, 1, 1, 1, times, 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 1, 2, 3, 1, 2, 3. The pattern is, as this stays the same, this goes up 1, and this goes up 1. And again, that pattern is what I want to use to figure out my rules for integers. By the way, the first rule is up here right now, because isn't it true that no sign means positive? So 1 times 1 equals 1 really says a positive 1 times a positive 1 equals a positive 1. And a positive 1 times a positive 2 equals a positive 2. And a positive 1 times a positive 3 equals a positive 3. So what does that rule say? It says a positive times a positive equals a positive. All right, and again, that one should not cause you any trouble because that's what you use ever since you learned to multiply, like in 3rd grade. You've been using a positive times a positive is a positive. Now I can use the same pattern to figure out another one of the rules, but not by using the pattern going up, but by using the pattern going down. And you go, I don't get it. Well, follow. Positive 1, positive 1, positive 1. The pattern is this always stays the same, so this is a positive 1. Times, times, times stays the same, so that's a times. Now here, positive 3, positive 2, positive 1, what's the pattern there? It's going down 1. So what's 1 less than 1? 0. And again, equals, equals, equals stays the same, equals. And then a positive 3, positive 2, positive 1, the pattern again is it's going down 1. So this becomes 0. By the way, this is not a new rule, but it does prove that the pattern does continue to work going down. Because isn't it true that a positive 1 times 0 equals 0? Because the property of zero multiplication says anything times 0 equals 0. So again, a positive 1 times 0 is 0 is true, but it's not a new rule. So we continue the pattern. Positive 1, positive 1, positive 1, positive 1. We stay a positive 1, because this always stays the same. Times, 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 times stays times always the same. Now, a positive 3, positive 2, positive 1, 0. It's not blast off. I can keep going down. And what's 1 less than 0? A negative 1. Equals, 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 equals stays equals. And a positive 3, positive 2, positive 1, we're going down again. So what's 1 less than 0? A negative 1. And now I have a new rule. A rule for a positive times a negative. And the rule for a positive times a negative equals a negative. And by the way, without even using a rule, okay, I can figure out what a negative times a positive equals. And you say, how could you figure out what a negative times a positive equals? All right, I say, because of the commuter property of multiplication. And you say, what? I heard of that before. Yes, you did. A negative times a positive is the same as a positive times a negative, because the commuter property of multiplication says you can change the order and the answer will stay the same. It won't change. So if a positive times a negative equals a negative, then a negative times a positive also has to equal a negative. And now I have 3 of the 4 rules I need. There's only one I'm missing. The one I'm missing is a negative times a negative. And you say, well, Mr. Dude, that's got to be a negative. And I say, no, it doesn't. And you go, yes, it does. A negative and a negative, you bring down a negative sign. That's addition, not multiplication. And you say, but I don't get it. Why could it possibly not be a negative? And I say, well, we have to find a pattern again. But not a pattern for the 1 times table, a pattern for the negative 1 times table. And you say, I don't know a negative 1 times table. And I say, well, you could find one now, because since we know that a negative times a positive is a negative, we could start with a negative 1 times a positive 1. The rule says always multiply. 1 times 1 is 1. And the rule says a negative times a positive is a negative. So a negative 1 times a positive 1 is a negative 1. And then a negative 1 times a positive 2. Again, 1 times 2 is 2. Always multiply. Negative times positive is a negative. Your answer is a negative 2. And a negative 1 times a positive 3. Again, a negative times a positive is a negative. And 1 times 3 is 3. So now I have the start of a negative 1 times table. And I'm not going to keep going up with it. I want to go down with it again. And again, to find a pattern, negative 1, negative 1, negative 1, the front always stays the same, so this has to be a negative 1. Times, times, times stays the same. Now, positive 3, positive 2, positive 1, I'm going down 1. So 1 less than 1 is 0. Equals, equals, equals becomes equals. Now here's the tricky part, so follow along. Negative 3, negative 2, negative 1, 0. And you say, yeah, because I'm going down 1. That's not tricky. No, you're not going down 1. You're actually going up 1. Because 0 is larger than a negative 1. Because wouldn't you rather have nothing than 0,1? By the way, a negative 2 is smaller than a negative 1, because I'd rather 0,1 than 0,2. and a negative 3 is smaller than a negative 2 because I'd rather O2 than O3. So really, this is not going down 1. This is actually going up 1. So if I want 1 more than a negative 1, I get 0. And again, the property of zero multiplication proves that this is correct, but it's not a new rule. But let's continue it one more time. Negative 1, negative 1, negative 1, negative 1, negative 1 again, times, 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 positive 3, positive 2, positive 1, 0, and again I'm going down 1, 1 less than 0 is a negative 1. Equals, 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 negative 3, negative 2, negative 1, 0, and remember I'm going up 1, and 1 more than 0 is a positive 1. So it turns out that a negative times a negative is not a negative. A negative times a negative is actually equal to a positive. And by the way, this causes people a lot of trouble because this is where people get confused, okay? Because in addition, a negative plus a negative, you add and bring down the negative sign. So when you're adding, a negative plus a negative is a negative. But in multiplication, a negative times a negative is a positive. We just proved it. So don't mix up addition with multiplication. And you say, but I don't get it. Why are they different? And I say, because multiplication is not addition. They're different. Think about it. Do you add fractions the same way you multiply fractions? Do you add decimals the same way you multiply decimals? So why would you add integers the same way you multiply them? But you have to keep straight which rule is which. And I'm telling you now, people mix up a negative plus a negative with a negative times a negative all the time. So be very careful to make sure you stay the same. By the way, the fact that a negative times a negative is a positive does confuse some people, but the fact that a negative times a negative is a positive makes it easy to take your 4 rules and boil them down to 2 rules. And those rules would be this: same sign, answer positive. And different signs, answer negative. So again, just like in addition, when I ask myself, do I have the same signs or different signs? And if I have same signs, I add. And if I have different signs, I subtract. In multiplication, you ask yourself, same signs or different signs, so you can figure out the answer, the sign of your answer. If the same signs, your answer is positive. If the signs are different, your answer is negative. But you always multiply, and you got to multiply correctly. By the way, about 10 or 12 years ago now, time flies so fast, I taught a little girl named Alexandra Ibieta. And Alex came one day to class and she said, Mr. Dew, a friend of mine told me an easier way to remember the rule for multiplying than same signs answer positive, different signs answer negative. And I said, well, maybe she came up with another way, but I don't think it could be any easier than this. And she goes, no, it really is. So I said, okay, what is it? And she said, well, think of positive as love and negative as hate. And that was easy to remember because love is a good thing, it's positive. And hate is a bad thing, it's negative. I said, okay, but how does that tell you that a positive times a positive is a positive? And a negative times a negative is a negative, is a positive. And she said, it's easy, think about this. If you love to love, you're gonna love because you love it. And if you hate to hate, you're not going to hate because you hate to hate. If you hate to hate, you're going to love because you hate to hate. And if you love to hate, you're going to hate because you love it. And if you hate to love, you're not going to love. If you hate to love, you're going to hate. Now again, if that confuses you, forget about it. Okay? But some people actually like to use that. I found especially girls like to use it. Okay? As a matter of fact, my daughter, Allie, ran into one of her classmates when she was at St. Francis, Michaela Tassin, at LSU, and Michaela told Allie, you know what, tell your dad I still use love to love and hate to hate to remember multiplying integers. So it helped her, maybe it'll help you. Personally, I would use same signs answer positive, different signs answer negative. But you use what you're the most comfortable with. Now I will tell you this, be careful with same signs answer positive, because I catch people with this all the time. Now I'll do a -3 times a -2 times a -5, and they'll go 2 times 3 is 6, 6 times 5 is 30, so they say the answer is a positive 30. Wrong. You go, what? Isn't 2 times 3 6? It is. Isn't 6 times 5 30? It is. And doesn't it mean same sign answer positive? It does. And you say, well then why isn't the answer a positive 30? And that's because when you multiply, you can only multiply 2 numbers at a time. So you cannot multiply a negative times a negative times a negative. You can only multiply a negative times a negative. And by the way, a -2 times a -3 is a positive 6. But now when I multiply times a -5, I no longer have same signs. Now I have different signs. So a positive times a negative is a negative, and 6 times 5 is 30. So again, the rule same sign answer positive, different signs answer negative is true when you multiply in 2 numbers at a time. If you have more than 2 numbers, you can only multiply 2 numbers at a time and get that answer. So be careful about that, because I promise you I will wind up giving you stuff like that. Now your homework tonight will actually be on IXL again. So again, remember on IXL you got to try to, to get a mastery of either 80%, 90%, or 100%, and you want to aim for 100%. And as long as you know how to multiply, and as long as you remember same sign answer positive, different signs answer negative, you should be able to do good with that. By the way, I will send you rules on this too. So good luck on your homework tonight.